So thanks everyone for coming along to, we're up to Knowledge Share number 6 for the ACCS project, and we're very happy today that we're going to have Rubbiya and Hoang from UQ is going to talk to us about the deployment of Clowder, and specifically Pitschi, which we've all been learning about today is a gorgeous little kitten, and who did want in the end to be a kitten. So hopefully the storage does in the end want to stay as storage or something like that. Maybe that's the moral of the story. So without too much more fussing around, I'll just ask, Ruby is going to give us a quick introduction, and then Hoang will take us through some of the functionality and give us a bit of a demonstration later. Thanks, Rubbiya.
Yeah, hi everyone. So today's talk is about like this metadata repository framework, which we are trying to establish at CMM for UQ instrument. So we named it Pitschi because it's basically extension of Clowder, which is the group of cats. So our tiny little cat is Pitschi, which is really cute, and she was the whole life wasn't happy because she was a kitten, and she went through so many adventures, and at the end she was happy because she found that's the best way she can live in. So now in this project, we went through so many adventures as well. So we have been working on this one like in last 2 years. We tested many repositories, and this is the final one, which we think suits us, suits UQ, infrastructure, and all the researchers and clients at CMM. So going next. So yeah, so in start, I'll be talking about what CMM is, why we went for Pitschi, which are the objectives for this particular project, and then Hoang will join in to give a demo and the whole rollout discussion thing. So CMM, most of you know that like Center for Microscopy and Microanalysis is UQ's facility. It's a big facility. We have about like 24 staff members, which are like academics, research, technical, and administrative level as well. We do have a wide, diverse range of instrument platforms, which includes like electron microscopy and microanalysis, X-ray diffraction, and image spectrometry. All these instruments are basically operated on 4 different sites at UQ St. Lucia campus. So there's a big networking involved in all these different sites, which needs to talk to each other within this network. And that was the main issue we dealt with before coming to this decision. So I'll be talking about that later. In brief, what we provide to our clients, a data management analysis and visualization expertise using CMM facilities. So this is a typical workflow we have at UQ. So first thing, when you generate data, you need to store it somewhere. So that's where UQ RDMs come in. It's a system running in UQ. When a researcher come into CMM, he does obtain a collection. He applied for that, and once exceed the allocation, he get an email. So when the data comes out of the instrument, it goes into those collections. The good thing about those collections is they can be mounted from anywhere on the UQ network. So what we did is we have like instrument collections. So all the data coming out of the microscopes are landing into those RDM collections. From researcher's point of view, he accesses data from those RDMs, and the good thing is we have other systems like Nectar and CVL, supercomputer, HPC. So if he needs to use that data, you can use it using through this data fabrics MeDiCI. So at the end, it is like RDM can facilitate data linking back to for durable URLs. These things are like managed by UQ library. Going next, please. Okay, so the main thing we were trying to achieve was a findable, accessible, interoperable, and reusable metadata repository framework. And Pitschi is the thing which we found, and we tried our best to get all these aspects in this metadata repository. In CMM, we are already using 3 different systems at different levels. So one of them is VPMS, which is a instrument booking system, and basically the control, I would say like the controller of the instrument instruments are controlled within this system. The licenses are provided to the users, and all these things are happening in this one. It's a project-centric, it has a project-centric approach. So each client has their own projects, and all the data related to those particular project, doesn't matter which instrument they are coming from, are managed in this VPMS booking system. Then it comes to storage. It's UQ RDM, which we are using in CMM. And when users get their data, they need to process it. That's where we are quite rich at UQ. We do have like Wiener and different HPCs. And the best thing we have is CVL at Wieners, which you virtually can access and use your you can do your like data analysis in there. So what Pitschi does is basically a complete, we try to establish a complete workflow. It basically integrates all these three systems. So starting from PPMS to store the data in UQ RDM and then process it in CVL. So while designing this workflow, what we consider was like a complete data lifecycle. So as you know, like these are the basic parts of a data lifecycle. So you collect your data, you store it, you use it. It needs to be archived or deleted, whatever way you want to do. And then at the end, it should be publishable. But if you go into detail, when our data is stored, it can be done manually, automatically. So these kind of things needs to be taken care of while talking to a complete framework. So data transfer needs to be automated. It needs to be secure. So for example, in our RDM instrument RDM collections, all the users can access all the data generated from the instrument. That's where like I think security risk comes in, which we try to cover in this particular workflow. Then the data needs to be backup and recoverable. And if a file moves somewhere within RDMs, it needs to be traceable. So when it was moved, why it was, like who did it, and if it's deleted, when it was deleted, those kind of things. So when it comes to usage, the most important thing is like when you talk about a fair data repository framework, our data needs to be really rich, and it needs to have all the metadata related to when the experiment was started, when it was generated from the microscope, what were the observations by a scientist or whatever. So those kind of metadata is really helpful in the long run when a new researcher comes in, or even the existing researcher wants to see, okay, 3 years back I did this experiment and I need all this data from that particular result. So he can go back and check all those settings or whatever like metadata related to that particular project and use that. So that's where we come in, like it's reusable. Then of course, when a image come out of microscope, it needs to be realized. So realization and processing, and then if it's modified, it needs to be resaved. So that's where we say data is recreated. So more files in the repository. That means it will be increasing the volume of data after each experiment. So it needs to be managed somehow. Then in the archival, it's of course, it needs to be archived and protected, and it should be easily available. Even like after 5-6 years, there should be a way that there should be a quick way, I would say, to retrieve your files from the archives. And if you don't delete data, you can keep on generate data, and then the files will be multiplied when you will process them again and again. So there should be some way where you should kill the process by the data, if the data is rubbish or it's no more needed. A researcher who is working on that can define that. So it needs to be deleted to be efficient, cost wise and energy wise. And then it should be accessible worldwide. So if you go anywhere, you should be able to access it, and it should be shared with you. For example, if someone is not from UQ, in CMM case, we deal with industry partners as well. So if we want to provide that data to externals, we should be able to share it with them.
Rubbiya, you have a question from Jason. So question around linear presentation where data publishing happens after archival and deletion. Can you comment on that?
Sorry, where is the question?
In the chat folks.
Sorry, I can actually ask it out loud. Rubbiya, my question was, and I'm just trying to make sure I understand this correctly. You've got a sort of linear model which makes perfect sense for the first three things, but do you have a process by which you're archiving your data or you're deleting it and then you're publishing it? Because I'm struggling a little bit to understand how that would work. Is it actually meant to be, the last two are meant to be swapped around, or is it a parallel process where, you know, the data usage forks on one hand into archival and on the other hand into publishing? I'm just trying to understand the visual representation you've used to explain how Pitschi works.
Yeah, okay. So looking at this linear presentation, this is how normally, like when you don't have a standard image data repository, this is how like we just go with the flow. I mean, we don't think of like if we archive, we need to reuse it. When you reuse it, you go back to data usage, and then it go back to data storage when you save your processed data. So this is just a normal flow. That's how we normally work when we don't have a fair image data repository framework. But definitely we need, it's not a linear one. It's a circular life cycle, and it goes back and back and back. That needs to be, you know, taken care of when you are establishing a data repository.
Yeah,
so,
no, I guess I was trying to figure out it's awfully hard to publish data after you've deleted it.
Of course,
Finally, have a data cycle in the chat. It's a diagram we discussed
thanks,
in
Roger.
package 4. The aim is to create such a data cycle, but we are not there yet. We just get the repository up and store everything. Delete is not an option up front before we know how we implement policy. Yes.
Okay, so the main objectives of this project were like we did a lot of analysis, like a big analysis with the buildings and networking. So with the networking, we had at buildings the custodians of instruments. So after doing all those things, so the first thing we dealt with is the networking issues. So because like each building had like a different network setup. Like some of them had like the different protocols, and the protocols need to talk to each other within building and within like UQ campus and all that. So we took care of that, and it took about like a couple of years to fix all the, and we're still doing that. Like it's not done, but we are trying to fix the things as much as possible from the networking side. And then the objectives which we dealt with during this design. So what we wanted was when a data come out of an image come out of a microscope, when it is captured, it should be transferred to raw data to storage collection, which in our case was the RDMs, and then each image should be indexed within the image repository, so that it should be like searchable later on and all that. So, and it should be completely synced with our booking system, because that's basically kind of controller to our instruments. Then because we are running a project-centric approach in CMM, so the storage collections were previously with the instrument files. So this was the change we made, that storage collection needs to be per project. And the good point about that is, for example, if I do a PhD in 6 years, all my 6 years data from any instrument within UQ should be accessible in one place, in one collection. So this is how we finalized. This was the approach we had. So move away from one storage to per instrument model. This is what we did. And yeah, like I mentioned that it needs to be fair, and that's where metadata is highly important. So easier for users to view and search their data and later process it to another platform. So for example, CVLs or anywhere, yeah. And the most important thing is as simple as possible for users to deposit data. So we dealt it with in two ways. So we do have like in Pitschi, we are using like web version of Clowder as well, so they can like just upload it using the web browser, and we mount the collection directly to the instruments project wise, and they can just land their data in there. So these are the main objectives when we were establishing this, we took care of. So next one. So yeah, okay. So this is a collaboration between RCC and CMM. Hoang is from RCC, and he has been working like throughout this process. So I'll hand it over to Nguyen, and he'll explain the structure of this Pitschi framework. Yep.
Thank you, Rubbiya. So next, I will talk about our image repository implementation for Pitschi. So first, I will briefly introduce Clowder, so why we selected it. And we will talk about our modifications or implementations. And then I show how data is ingested into Clowder or into Pitschi. And then after that's a demo. So Clowder is an open source data management from the National Center for Supercomputing Applications in the States. And some of you may have heard of FOSIT. It is an implementation of Clowder that focuses on material sciences. So this framework is an established one. It has been used in many organizations and in multiple disciplines. So early this year, we have conducted an evaluation process and we selected Clowder over a wide range of existing data management solutions. And we have presented it to MA directors early this year. So in Clowder, data are organized into spaces. And under space, you have data sets. And under data sets, you have an arbitrary hierarchy of folders and files. And you also have collections, which is a virtual group of data sets. And the access control in Clowder is done at the dataset level. So Clowder provides a powerful search capabilities. So you can search based on the names, the space, datasets, and files. Or you can do search over metadata. So you can do search over a particular fields of metadata and files or datasets. And Clowder provides automated metadata extraction, and it supports many file types, but it is also extensible to add new extractors, which is the term in Clowder for a plugin that extracts metadata out of files. And importantly, Clowder is very flexible for in terms of data ingestion. So the data can be ingested from client side, so from the web or any client that talks to the Clowder REST API, or the data can also be ingested server side. So somehow, if the data can be transferred by other means to the server, and then you can just tell Clowder to index the data at a certain location on the server. So this is important, and I will explain later. Now, so with Pitschi, our implementation of Clowder, so we have modified Clowder. So remember the objectives that Rubbiya said earlier. So we have modified Clowder so that we map the projects in our booking system to a space. So space is the highest level of data organization in Clowder. And each project is mapped in from VPMS is mapped into space. And together with the space users. And each space has its own storage collections for storing raw data. I stress raw data because in this model, the processed data should be stored elsewhere. The project IDMs, we only reserved it for storing raw data. And the data sets in Clowder or in Pitschi corresponding to a folder in RDM. And each project IDMs collections, the project IDMs are automatically mounted to Clowder. So this is a screenshot in PPMS, the booking system used by CMM and later used by UQ RIMS. So we have made a small modification in the profile. So we have requested Stratocore, which is the name of that company maintaining PPMS, to add a new tag called UQ RDM collection number. And this is the name of the collections that correspond to this project. And
Hoang, can I just interject there for 1 second? Jason's asked a question there about just determining whether the project is a separate space or whatever. I think you're answering it now, but just that question there is each project a separate space? So each project has its own Q folder. Is that the understanding?
Yeah. So if anyone wants to ask a question, just feel free to interrupt me. You don't.
Yeah.
Because
so Hoang, I know you've said in the slide. I'm just trying to make sure I understand it correctly. So, however many projects you have in UQ, the Clowder actually allows for you to have a lot of spaces, because you could have thousands or tens of thousands of projects over years, but each one will be a separate space. Is that correct? With its own hierarchy of how it's sorted into data sets and so on?
I will explain about that later. So
Sure. Cool.
The collections are actually managed by IDMs. So for each project, we will request them for one project, but that's a model.
Right.
Yeah. So at least that's what we aim to.
I don't know.
Because at the moment, the model that CMM has is that each instrument is one collection. And the problem with that is it has a lot of users in it, and then meaning that users can see other people's data, and well, they can do whatever they want, modify it, delete it. Obviously, there hasn't been any case, but it's still not. I don't think that's a good model, though. So that's why we aim to have a single project, a single space, a single collection for one project. Okay, I will just continue then. So with this on the right side, so this is the space or the view you have in Clowder. So each of these projects is synced to Clowder, weekly. So and so far we only sync projects that has this valid tag in it. And the reason to sync it weekly because in CMM the decision to approve project is done weekly. And as part of that synchronizations, Pitschi also syncs users that belong to that project into Clowder. And then users can just log in UQ SSO to log into Pitschi. Now, in order to do that, we will make a slight modification to the project registration process in CMM. So especially the users will be asked a few more questions, especially those related to the storage collections. So for example, like the estimation of how much data they generate, obviously that number can be modified later. And whether it's related to human data, because if it's human data, then it cannot be stored in the IDM key collection. It has to be dealt with some in another way. So as soon as the project is approved, we, well, in this case, Rubbiya and myself, then request the IDM collection to be created with the UQ Pitschi, which is a CMM service account, as a collaborator. The collection number is then updated to VPMS, and then the project is synced to Pitschi automatically in a weekly basis. So this process, the registration process, has to be done manually at the moment, but we will automate it as soon as possible. The main reason we cannot automate it is because of the lack of APIs from the collection creation.
Can I ask, if you already have a Q collection, can you ask that it be that Pitschi is a collaborator on that existing one that you might have?
Yes, I will cover it in the last part, but yes, okay. So to answer the question, so we will deal with existing, we deal with new projects first. Okay. So for those new projects, we will ask them to create IDM the new collections. For the existing ones, once everything is rolled out, and using normally, we will start ingesting those existing projects into Clowder later on. But that's not the highest priority at the moment.
Okay, sorry, I'll be quiet now.
No, it's no. Feel free to interrupt. It's okay. Okay, so the next part is how the data is ingested into Clowder, into Pitschi. Sorry, I keep using the Clowder and Pitschi interchangeably, but they're the same. Just Pitschi is our implementation. So with the user can ingest data in two ways. So they can just upload the data to the website, or Pitschi will capture the data right off the instrument computer. And with the second data ingestion method, we integrated the solution with Tracker. So for those who doesn't know VPMS Tracker, it is a client, a VPMS client that installed in the instrument computer to keep tracks of the usage of the instrument. So users are required to log in, log out, And then by that, we know how much user actually uses the instrument. But so either way, whether the data is ingested by the web or from the instrument computer, the data will land into the project's IDM collections and later on be accessible using other means like CDLs or HPCs, or they can even mount the drive to their desktops. And either way, the metadata will be extracted automatically, obviously for the supported formats only. So this is how the web ingestion works. So on the left side, you have the web UI for Clowder. So you go there, select the files, upload it. So once the files are uploaded, it will first land on a temporary storage and then moved into the queue collection that correspond to the project. So with this one, it is the easier option for me. But after talking with lab managers, it's obviously it requires users to do it. Then it's not going to happen all the time. So that's why we designed the second one. Now with this one, as I said earlier, the solution is integrated with VPMS tracker. So when the user comes in, he needs to have a booking in VPMS. So when the user comes into an instrument computer, he needs to log in into VPMS tracker, and this triggers a few things in the Pitschi system. So Pitschi will first check whether the booking exists. If it exists, then it will mount the project RDM collection into the instrument computer. And a folder will be created locally that corresponding to that booking. And then a shortcut code today will be created on that instrument computer. The user will carry on their normal activities, controlling the instruments, capture the data, and we only need to we only require user to drop the data into that today shortcut. And what's happening in the instrument computer is that periodically there's a process happening in the background. It will sync the data in that today shortcut into the project's IDMs. And later on, when we roll out, we will customize this syncing period according to the instrument characteristics. And once the user logs off, the system then finish syncing. It will then dismount the IDM collections, and then it will first send an email confirming that the data is already saved into IDM. And then it will try to ingest the data into Clowder. Once ingestion is done, then it will send a second email, which is very similar to the first one, but with the link on the data. And the metadata extraction is happening in the background as well. So this is the template for the first email. So basically, you say that the raw data has been successfully imported from the instrument name. So this is one instrument in CMM. And here's how you access the data. So basically, you can access using the Cloud IDM, which is a Nextcloud web interface. And then you can also look the data using from the desktops, and obviously with CVL as well. And then this is the second email, which is very similar to the first one. Apart from there's a first link here, we say Pitschi. If you click on this one, it will take you to Pitschi web interface. And when you sign in, you will be presented to the data that you just ingested. Okay, so this is how we implement Pitschi. So obviously, if your data is ingested on the web, then it will just it will eventually move to the queue collection mounted as NFS mount. Now on the instrument computer, there's a small client called Pitschi CLI. So what it does is it will check the bookings, and we actually buffer the bookings. We query the booking from VPMS to X API. And once the user logs off, this X API then ingest the data into Clowder. And I was asked once, why do I need this X API? Why don't I just have the Pitschi client query things directly to VPMS and ingest data right off Clowder. Well, the reason for that is threefold. The first one is if you are familiar with the Pitschi API, you will know that you will need to make a few calls. In this case, I think it's 3 calls to get all the information related to the bookings. And then it will slow down the login process. The second thing is related to security. So with the PPMS key that needed to make queries, it is the key for admins. And I'm not really comfortable leaving the PPMS key lying around in instrument computers. And then the third case is, the third reason is this X API will act as a buffer, as an abstraction layer on top of PPMS and Clowder. So later on, this solution can be extended to support different booking systems and even support different image repository, as long as the image repository supports server-side ingest. And once the data is in the data fabrics, it then can be accessible from HPCs, virtual desktops, real desktops, or other portals. Okay, so with this, the second, the direct ingestion or ingestion from the instrument computer, the PPMS tracker can be replaced just by UQ login. The problem with that is it wouldn't work for some of the cases where the instruments would require a certain program to be on all the time, because it involves recalculations of the instruments if the program is shut down and open again. And the second way of ingest, it works with most of the instruments in CMM, apart from 3 special cases. The first one is the instruments with a very long booking, like a week-long to month-long booking. And the second case is that it's a setup that consists of multiple, in this case, 3 computers. And the last special case is that the setup should require pre-processing. So in this case, the user needs to enter some numbers that acts as a parameter to start off the pre-processing. So three special cases. I will deal with it last in the rollout. Okay, so before going into the demo, is there any question? I know that you enjoyed the lunch, but I just want to make sure that you're awake.
Hey, I gave up lunch for this, so I'm definitely awake.
Okay, good.
I think they're all awake, yeah.
Okay. Okay, let's go to the demo then. So in this demo, I will show 3 things. So first, I will show the Clowder web interface. The second is I will show how web ingest works, and then how the data is landed on CVL and other platform. And the third thing I want to show in this demo is how Pitschi captures data of the instrument computer. Okay. So let's go to Pitschi. Okay. By the way, so with this login, so there's 2 ways to log in. There's email and password. So this is reserved for external clients. So those who doesn't have UQ SSO. And those UQ users just click on this green button, and then it will take you to the Pitschi. So it's go to explore and then spaces, and it will show the projects or the spaces. So each of these corresponding to a project VPMS. And under space, you have data sets. So as you can see that these are the test data sets that Rubbiya and myself have been ingested into Clowder. So let's look at one particular data set. So in this data set, you can have folders, you can have files, and you can click on one of the files, and then it will show the details of the file. So the file size, upload the date, that kind of thing. You could have a thumbnails as well, and then you'd have the metadata. So note that the thumbnails and the metadata are automatically extracted by Clowder. Then let's do search. So you can do search based on file name. So let's say that let's show me all the files that with this name, for instance. So it's yeah. So this is nothing fancy, but let's do a search based on metadata. For example, let's go back to this, right? Let's say that I want to list all the files that have a bit depth of 8. So let me just say that. Click on these and go to metadata search. So click on depth and maybe click on a bit. So it could show, it will then list all the files that has that parameters, and you can add more terms in that search search box. Okay, next I will show how the data is organized in Pitschi and how it the corresponding view in CVL. So let's look at that data set again. So so these data sets, before going into that, so this page, it has all the information here. For example, this correspond to a UQ RDM 3504. Let me just open CVL. Should have a desktop. Okay, there's problem connected to the virtual desktops. Okay, here we go. Okay, so the collection is Q3504, and each of the datasets corresponding to the top level folder in that Q collections. And if you click on that folder, then all the files and folders in that datasets will correspond to the structures in Clowder or in Pitschi. Now let's try to add a some files, some small files. So this is the web ingest, by the way. So let's add some small files, and then you would expect that the same files will land in or appear in the Q collection in CVL. So if I just add a this file, I prepare some some of these. I really not this one. Upload it because these are this small files, so it's very quick. So these are the two files that I just added. So once the data is added, what happens is that the Clowder will get the thumbnails and the parameters almost right away, depends on the size of the files. So these are the metadata that is thus extracted out of the file. And if you look at if you look at CVL again, let me just refresh it. So these are the two files I just added. So yeah, so that's how web ingest works. Okay. Okay, is there any question regarding the Clowder interface or web ingest? Okay, I guess no then. Okay, let me show how the how Pitschi will captures data from the instrument computer. So if you can see this screen, so this is a splash top screen from an instrument computer in CMMs, and this is what VPMS tracker looks like when the user comes in. They are presented with username, password, login, and they need to log in order to use the instrument, and they need a valid booking as well. So let me just do a okay. So once log in, there's a few things happening in the background. First is Pitschi will mount the collections that corresponding to that project. So in this case, this is the Q collection that I just showed earlier. So this is mounted automatically. It also creates a folder, in this case in the C drive, and then my username, the date of the booking, and then the project. So when the user acquires data, they need to drop the data here. Let me say just create a folder called demo to ACCS. So this the name of this folder will be the name of the data sets in Pitschi once it's ingested into Pitschi. Let me just copy this the test data that I prepared. So these are rather small data. I think it's about a few gigs of data. So it's just for testing. So this is to mimic the actual data acquisition process happening. So what happens in the background is there is a process that running in the background. So user can still use the computer when this is happening. And for this particular case, because this is for demo, it happens once every 5 minutes. But like I said, when we install on instrument computer, we will trick it based on the instrument characteristic, like how much it generates data, that kind of thing. So I will also open the Q collections. So after a few minutes, you will see that this demo ACCS appears in the Q collections. And then once you logged out, you will receive some emails. So while waiting for that, is there any questions?
Is a logout a key part, Hoang, where you're saying on actually logging out that actually triggers certain actions to happen? So that's why it's a problem if you have a long experiment, because you might not have the logout to make triggers happen, or is that just a coincidence?
It triggers the action, yes,
right.
But then it doesn't necessarily triggers it. The thing is, if the user logs out, they get the data, right? So the data is ingested to Clowder right at that moment because I have that signal, right? But also what's happening in the background in that X API is it also checks the bookings. So let's say that if the data says it's in the systems, but it's not, but the system doesn't receive any signal of logout after 1 day, after 24 hours, it will ingest the data anyway. So the reason for that is for cases like, for example, when power outage, all of a sudden the user cannot log out or they forget or whatever, right? So, but in case the user forgets, they still charge for still occupying the machine. So it's not a big problem. But the bigger problem is, yes, like for things like with the power outage or anything that happens out of user control, then there's still something in that X API that's happening that checks that case. But yes, that's a very good question, Jason, because so technically that long-running experiment, I can still manage it with this workflow, but I just need to test it. So you can see that demo to ACCS appear there, if you can see it at all.
So can you deal with someone from the same group using the booked person's booking because that booked person's experiment failed?
It will just land on the same collections.
Right, so it'll end up in the wrong person's collection.
No, see, if well, because this one I cannot control, right? Because if this is based on the users and then the projects. So if that person happened to be in the same group but different projects, then yes, it will land on the wrong project collections. Right, but if the user, if they're in the same project, then well, it's the same. It's the correct location anyway, right? But yes, that's a very good question, James.
Just have a drop down that pops up at login to say, based on your username, which projects you've got, and then you can select where you want it to go to.
Actually, it does.
It does show that. It does show that. So what happens when you log in, it will show you a drop down and all the projects belongs to you will appear. You need to select the right project.
Yes. The funny thing is because before this, I've logged in to check 2 times. So I think it remembers, but it does. The if the user logs in, the standard, I'm not sure whether you are using PPMS tracker, James.
I write my own because theirs is very limited in what it can do. So you can only enable or disable whether you need a booking or not that you belong to the same group and things like that. So we've written our own to handle those sort of situations. And we also have individual login into the PC rather than admin log into the PC and then use the tracker to block the screen, so that you actually log in for each user and track for that, and then you shut down the computer when you're done.
So we can't shut down the computer on our systems. Basically, that's the issue. Yeah.
So James, I do have well, actually, before this demo, which is using PPMS, I do have it working with UQ login. But like I said in the slides, there's some cases in CMM, a certain program need to be on all the time. So I cannot use it, but it do works with UQ login. So with UQ login, you don't even need to see PPMS tracker.
Yeah.
But you still need a valid bookings to start.
Yeah. How do you deal with massive, like terabyte single files that are being added to, well, you're not doing time lapse, but you're doing serial sectioning that are growing over time? You don't want to write those out as they're growing, I assume.
So with that, there's another flow that I don't show here that it only syncs at midnight. I'm not sure whether that works for you.
Maybe, but some machines we shut down for stability. It's better to restart them. I think for these sort of situations, we've looked into the past. What you need is a separate data store that's connected by a fiber in the room that stays on all the time.
Yep.
But it's funny.
So with the pre-processing case, we do need to transfer the data into a Linux box. So that I think that could be very similar to that case.
And we have the plan in the rollout at the end actually to hook up the large data generators. So yeah, we'll have a learning curve. That's a steep one at the end. So there's no technical perfect solution around at the moment.
Yeah, they've all got their unique issues. Mm-hmm. I'd like to talk to you about the X API at some stage too. That would work really well for mine because I've got that same issue with storing API keys.
Oh yeah, yeah, because that the main reason I do not want to store any sort of credentials in the instrument computer is exactly that. So in terms of Clowder, that's probably not as bad because the API is restricted to a certain user. But then with PPMS, it is an admin key.
Hey, Hoang, can I ask a quick question, buddy?
Yep, yep.
Maybe you've answered it. I'm sorry if I missed it. Can you just tell me what's the biggest file you've currently tested this with?
Oh, the biggest file is just a few gigs really. So it's not it's not like a huge file.
That's ginormous.
Yeah.
What about as a collection? So what about multiple files?
Multiple files because we rely on IDM. So I don't think the size of the collection should be. I'm not saying that it's not independent from it, or it's not. It doesn't depend on it. But I'm just saying that because we rely on the IDMs. So and because we sync once every I don't know, like at a certain interval. So you don't sync let's say that you have 500 gigs or 1 terabyte data sets, right? You don't sync that big block of data once, but you sync incrementally. So probably it would deal with a large data sets that has many files, probably better than James' case where it has like a single huge file.
Yeah. Okay.
But like I said, we in the rollout later, I will explain a bit about our strategy for rolling out. So we will be rolling out for most of CMM's instruments first. So those instruments, they generate like small to medium amount of data. And with the large data generator, we will I think we would need to test it very carefully to optimize the configurations, because all those configurations, like how often it syncs and where it syncs to, it is all configurable. We just need to trick it with the so that it works best for those instruments.
Thanks, Juan.
We can use bioformats, right, for the metadata?
Yes. So in fact, as part of this project, one of the first things that I did is to create an extractor for bioformats. But
I give you some data sets and we can see how it handles optical microscopy.
Yeah. Actually, I get some of the files. Later on, I show you some of the files from some of the collections.
Cheeky.
No, it is the test data, so it's not. So is there any question before I log off, and then we see the emails?
There's a question in the chat from Hoang.
Let me see. Sorry, like chat, I don't see.
Hoang has asked, I'll read it to you. It says, the NFS drive of MeDiCI is not exported to instrument computers, but is to the Clowder PC only, yeah?
NFS drive of MeDiCI. What do you mean, Chung?
Hi. Yeah, because from your slides, I can see that there is an NFS mount, and that goes directly to Clowder, and so that doesn't connect to the one that with PCCRI. So I'm just confirming, like, does this NFS drive or storage folder will be like, are they made available to the instrument computers directly, so that
okay, I understand it now. I understand the question now.
Yeah.
Thanks. So in UQ we have a system called MeDiCI.
Right.
I'm not sure whether you're from UQ or from other organizations.
I'm from ANU.
Okay, yeah. So so let me explain that a bit. So with MeDiCI, basically it is a way to expose the data or the collections using different means. So for example, can I come back to the question later on? Because I want to log off and then show everyone an email and then I explain about that. But thanks for the questions. Okay, so let's just log out. So okay, the log out. So when the user logs out, they basically signal the system that okay, I'm done with it, and then there should be an email sent to your mailbox. There you go. So here, so this case is for people like, okay, like, because there's certain researchers who doesn't care about a mixed repository, right? They just want their data to be in RDMs as soon as possible, and then they can go somewhere else and start processing. So the first email is for that. So in this, let's say that they can access to cloud RDMs and this one. So this guy, this is the data sets I just created demo to ACCS, and then video and large here. And then you can also mount this to the desktops. So this probably answers the question, Chung. So MeDiCI is a way to expose collections using different means. So basically, you can mount the same collection as NFS mount to Pitschi. Right. You can also mount the same collection to the PC, to the computer as an SMB mount.
Did you say XM?
SMB Samba mount.
Oh, okay.
So for example, this appears in my PC, right?
Right.
So this demo to ACCS one. The same thing, if you go to RDM, if you go to CVL, in CVL, the collection is mounted into the HPC, and then yeah, demo to ACCS one, yeah. So it's a way to simplify the way you access to the data. I'm not sure whether I explained it well, but yeah, we can.
Could you repeat again the mount that you say?
Can you say again?
Did you say NFS mount, or did you say X? What was that? What was the mount that you said?
It can export the collections using different ways. So it can export as NFS mount. It can also export as a Samba mount to your PC.
Oh, okay, okay, yeah.
So that you don't have to worry about where the data stays really. And then you can also look for other things, other processing platforms like CVL or the image processing portal.
Mm-hmm.
Yes, I hope you don't mind. So this what's the image processing portal is probably a topic for another talk. But basically, you so with this, then you can access the data using different ways once the data is in the fabrics. Right. And after a certain period of time, once Pitschi has successfully ingested data, then there will be another email saying that it's successfully ingested, and I will show you that email later when it is available. Okay, so to recap, let's go back to the slides. So we have modified Clowder and integrated with the UQ data fabrics. We also implement Clowder in a project-centric approach. And then with the web ingest or server-side ingest, then we have simplified the way that the data is ingested into Pitschi. Okay, so now where we are. So we are in the rolling out phase. So after talking with lab managers, we understand that this is a big change for CMM. So that's why we will be doing it slowly and carefully. And the ultimate goal is to minimize the disruption of services. And there's a few priorities that as part of the rolling out strategies. So first, we're rolling out with Windows 7, Windows 10 and 7, and then Linux and XP last. We'll be rolling out from the less busy instrument to busy ones, obviously, and then from simple setup to a more complex ones, and small data generators to big generators machines, just to test and perfect our solutions. And obviously the UQ users are prioritized. And as I said earlier, we will be prioritizing the new projects. We'll be asking them, we will be creating key collections for them. And then existing projects, we will deal with it later when we will start ingesting data of existing key collections. And so after the demos, so we did a demo to the CMM staff and to ACCS. After this, in the next 2 months, this month and next month, we will start rolling out with 12 first instruments, 3 from each lab, and then the rest in another 2 months. And then after that, it is XP and Linux. And those are special cases we will deal with it last. I know that the challenges are still ahead of us, but to get this far, I would like to acknowledge a few people. So first, from CMM, I'd like to acknowledge Professor Rosa Webb, Travis, and Carlos, who I'm helping Rubbiya and myself to collect the instruments, collect the information, the instruments, and the lab managers and instrument owners from CMM. From RCC, it's Professor David Abramson and our CTO, Jack Carroll, And from ITS, this is Rose, Leslie, and Stephen. And we would also to thank ICCS to give us this opportunity. And last but not least, I would like to thank MeDiCI and the IDM team to make the data really virtual in UQ. Okay, with that, we are open for discussion.
Could I see some optical data in Pitschi?
Yep. Let me just open it. Oh, I need to show it again. I need to show share screen. Okay. So this is just one file that I got from one of the tests that I ran. So this is I think you are familiar with this, James. So
yeah, lattice.
Yeah. So in terms of display, I think we need work on that. So at the moment, it just shows the very first slides. But then this is the metadata that it gets. I can give you an account if you want to test it.
Yeah, that'd be good. Thanks.
Okay, so here's the second email. To say it's pretty much the same as the first one, but apart from this, say Pitschi here, if you click on the link, then it will take you to that data set. These two files, I think they're still being the thumbnail is still being extracted and the metadata is still generated. Yep. So any question?
Hoang, you may have said it. I'm sorry if I missed it. So the metadata that you get them from the instrument. Do you also get any from the booking system?
What do you mean metadata from the booking system?
Well, for example, ORCID of the user, description of the data, title of the data.
They don't. I don't think it's that kind of data is available in the booking systems.
Okay, but if you wanted to add something like ORCID of the user, is it something you could? That would
yeah, because so with the X API, I can actually pinpoint the file of a certain booking that belongs to a certain instrument. So yes, it can. So later on, I think Rosa has a plan to put a persistent ID on the instrument, so that will be appeared in.
Yeah, there's two parallel developments at UQ. There's a new version of PPMS, you can call it RIMS, which then will harvest ORCIDs from users and other stuff. And we want to also establish an ID system for instruments and equipment here. So these are parallel systems coming up during the year. RIMS should be available by the end of the year, and then would replace PPMS, which we harvest data now from. And to persistent ID, I don't know how fast we are. Rubbiya can give you probably an update, yeah, where we are there.
Yeah, like basically all the like the parameters we collected from each instrument. I'm collecting information from each instrument for PIDs as well. So I have collected all the data, and from there I'll be taking care of the rest of the like contacting people as well. But regarding your question about like what coming from PPMS, so yeah, we are exporting a project name from PPMS. So it will be like we need a standard name for a project. So it will be the same name coming from PPMS, and whatever information PPMS is will appear as a metadata here. But we can do like we have like customized field as well. So for example, if a user wants to enter like the temperature when the experiment was happen, so that's something he wants to save with the experiment, we can add those things as well.
Is it something that also you could capture from an electronic notebook?
We can, but
that's a bit far-fetched.
Yeah.
So Ben has a question: where are bookings made? So it's a PPMS.
VPMS,
Yes. And it's limited to specific software. Yes, yeah, that's a booking system that that CMM is using and UQ is using.
So it's a web browser, you can access it.
Hoang, a wider sort of question. Pitschi is currently a solution that looks like it's solving a widespread way of moving forward within CMM. Do you anticipate Pitschi might also end up in centers other than CMM that also have instruments that this could be used to solve problems?
I tend to not think that far.
Okay. Different where is Roger's empire growing as he sublicenses Pitschi to other parts of UQ?
No, it's open source. We don't own it.
So everything we do in this project is open source. So the only thing we keep is password files. Everything is open source.
I guess I'm appreciating the amount of work that has gone in to putting all of the open source components together to come up with a coherent narrative, which is excellent, by the way. Let me, congratulate you. Makes it feel like other parts of UQ could theoretically be interested in seeing whether they could adopt this in the same way that the RCC makes MeDiCI available to, QBI or other parts of UQ.
Like I said, I tend to not think that far.
Fair enough.
If it works, then it works.
Probably Hoang is more worried about the workload. So if you get an additional position, yes, I think that's no issue. Yeah.
Maybe let me rephrase Jason's question. How specific to UQ is MeDiCI? So
that's what I was really trying to ask. David's captured that really well.
So for example, UQ RDM or PPMS.
Yeah, MeDiCI is not something which we had in the project developed. Pitschi has been adapted to the local environment. Yeah.
So let me show you.
But it can be adapted to other environments as well. Yes.
We rely on MeDiCI for data transfer, but there's no reason why there's other means of data transfer cannot be used. Globals, for instance. But again, that's not my problem. So it's not my problem. But I think because at UQ we have the luxury of data to be virtual, so I make use of it. Otherwise, the data need to be transferred from one place to another, and I think that's a solved issue. That's a solved problem. So
people who used 4Seed in the past, they had even file server systems where they stored images on, and Clowder can actually extract data and put it somewhere else if you want. That's a possibility. So in principle, you could work with different file systems in the background. If this is the question you had about MeDiCI, yes, yeah.
David, is it fair to say you were just thinking through how this work or parts of this work could be adapted into other institutions?
Other facilities, basically how much customizable Pitschi is. If, so, for example, someone doesn't use PPMS.
Like I said,
another booking system, yeah.
So it's just because there's a X API that acts as an abstraction layer. So probably just a few more API calls, and then you can get the bookings and the users from other booking systems.
But it's trivial enough. Like they don't need to hire a developer for the next 5 years to get the interface with the booking system.
Probably not the booking system, but from the file transfer. Probably not 5 years, but because.
And Hoang has now been working 6 months on this project, a little bit more probably, but implementing Clowder and developing Pitschi seems to me doable stuff, which you can do with 1.5 FT or 1 FT, but Hoang may tell you a little bit a different story, yes. We spent a few nights as well.
Not just few, but that's
Yeah, and in addition to that, like because we have this RIMS coming in UQ, which is going to be rolled out all over the it's VPMS, but it like UQ wide, so it will be pretty much same. So that fits in this workflow already. So other facilities can easily adopt this one because they are going to use RIMS as well.
What data are you extracting with the API calls from PPMS?
Oh, quite a lot of data, James.
Yeah. So username,
projects,
yep.
instruments, bookings. So bookings, we have the details of the bookings. So actually, we had this discussion earlier, right?
Yep.
So all those information, James. So
yeah, okay.
pretty much everything. So in terms of bookings, I query it once every 10 minutes because I don't want to ping the API too often.
Yeah.
Yeah, with that 10 minutes, then I query, okay, this is a new bookings. Because the annoying thing with PVMS is that it doesn't, well, the API is quite bad really. But anyway, so it's, they don't just give the new booking system, they give you everything and then you have to get it, process it. And then that one API call doesn't provide enough information, then you have to make another API calls. And the third one, so that's why if I query the PPMS API right off from the instrument, it's going to take a bit of time, and obviously there's a key.
So they will write you a custom report with exactly the information you wanted, and you just call that custom report once a minute, and it will put out exactly the info you need. But it will be some random number of report, like report 27, and you have no control over that number. So that'll be different for every instance around Australia where they install PPMS, but the report can be the same. It's just the numbering will be different.
Well, I'm aware of that. So even in the implementation of XAPI, I even put that in the configuration. Like this kind of call, what is the report, the ID of that report name? So
okay. How do you deal with things like interventions and stuff like that? If someone went and used the instrument and there was like they're an admin and there was an intervention, because they report differently in PPMS from the running sheet, and I spent a lot of time passing all that together into something that I could work with.
With intervention, so you mean the assisted by thing?
No. So if Rubbiya or one of the people in CMM book out an instrument to fix something, and there's, it's all good, and she sends out an email, hey, it's all fixed, someone can come and use it now. They might say, come and use it for free or whatever. That's a booking, but it's a very different type of booking, and it won't appear in the bookings list. And you end up having to do a few calls. I found you've got to do a booking call and a intervention call. And just, sorry, this is probably irrelevant to you guys.
No, we operate slightly different. We ask somebody to come in and do a booking.
Yep.
And then use the instrument, yes.
Yeah.
Just to avoid all the extra work. Yeah.
Oh, well, that's why we do it too. But in reality, what we find is someone cancels their booking, or they don't cancel it. They say someone else in their group come and use it, or as a manager with interventions for repairs and things like that, you may just forget to close it earlier. And someone will, you're running into those edge cases basically. Saying how you deal with it.
But that's always an issue, that you have situations where there's nothing perfect available.
But do you think that the policy kind of thing instead of because if you
it's a training thing.
Because if you enforce everyone, okay, like if it's not those, then probably make another booking or something.
But it's not that easy in PPMS. It's not like Bookit or one of those. PPMS can be quite limited in some of the ways it interacts with users for cancelling bookings. If you cancel after the start of the booking, you can't cancel. There's a few limitations.
The admin can cancel later on, so immediately, yes.
Yeah, but that requires someone to be around to do it. So, we try and deal with making it flexible for users so that they can use instruments. So just by changing the logic in the code a little bit to deal with it.
As I said, if the different users, but then in the same session, the data will be landed in the other people's project. That's I think I don't think there's any way around it unless the user logs off and logs in with another session.
I mean, you could simply just say at login. I mean, it depends on what you guys want to do, but if you aren't about restricting users from using it, whether they have a booking or not. You can quite literally just check against VPMS or wherever what projects they have and just pop those up, and they can choose which project to save the data to and not worry about the, do you have a booking or not? My code boots them off if they don't have a booking, if they don't belong to the same group, and you can set timers and all that sort of stuff. But
so you can configure the tracker such that if there's no booking, that you can actually walk up, put your name in and put and use a project and start working, and it will register in the background. We didn't go down that route because in the past at ETH we had a lot of difficulties with this automatic sign up. And it didn't work smoothly, so it crashed from time to time, and we had to do all these manual upgrades. So we could do that. I don't know if the tracker has developed over the last 3 years.
They sort of do little bursts every few years.
But I would, at the moment, I would not try to establish that. Our clients usually book at least 2 days or 3 days in advance.
And if a person comes in and he doesn't have a booking, so we have a message which is coming like on Pitschi that you need to book a session, come back again when it's booked. So we are showing this message on screen if it's not booked.
We allow users through the control panel we've got to then book, and they've got like 5 minutes before they get booted off. And you click a button and it opens PPMS, logs them in, and then they can make the booking and stuff like that.
Looks like that no more questions.
Yeah, it sounds all quiet now. Yeah. Thank you so much, Rubbiya. Thank you so much, Hoang. It was fantastic. I think everyone's very envious of it, and if they can adapt it, it looks really fantastic. So congratulations, and thank you so much for showing it to us today. And if anyone has any more questions, do you mind if they write to you or email you?
No, feel free to email us. Do you want a copy of this slide, Catherine?
Yes, I'll take a copy of the slides, please. Yeah, and I will
send it to you then.
Yeah, we've made the recording, so we can distribute that later on. Yeah. And what's left is to say thank you so much. It was really wonderful. Really appreciate it. Thank you.
Thanks.
Thank you
for showing. Yeah. Great.
Bye.